Hey guys, I'm making this video series for VTU M3 students, and if you're 21 scheme students, then you will be writing the exam for the first time, 21 or 31, and for 18 scheme students who have M3 backlog. And if you like these videos, please subscribe to our channel and share these videos with your classmates and friends so that it will help them also. So in this question, f of t is given as 3t plus 4 whole cube plus 5 power t. This is a time domain function, okay, and it is a polynomial plus an exponential function. And we need to find the Laplace transform f of s, which is Laplace transform of f of t. And Laplace transform of f of t is the integral of the product of f of t and e power minus st with respect to t from 0 to infinity. But we actually don't need to integrate anything here because we have already listed basic Laplace transform, such as what is the Laplace transform of t power n. So if you have a term t to the power 3, t cube, t square, something like that. So t to the power n in general. The Laplace transform of this is n plus 1 gamma of n plus 1 by s power n plus 1. So if it is n here, it is n plus 1 gamma over s power n plus 1. This is not square root, this is gamma function. Gamma is another integral that you will learn in the future, but now you can think of it as log or something like that. You can find the value of gamma of some number. Okay, and it is popularly known as n factorial by s power n plus 1. This Laplace transform of t power n is actually known as more popularly known as n factorial by s power n plus 1, because if n belongs to positive integers, so if n is 1, 2, 3, 4, 5, something like that, then gamma of n plus 1 is actually n factorial. But if n is not an integer, if n is 1 by 2, 1 by 3, something like that, a fraction, okay, then you have to use this gamma of n plus 1 by s of n plus 1. Okay, so both are same. This is more generalized form, and this is for specific terms where n is a positive integer. In this case, where here if you expand this, you will get t cube, t square, t terms. Okay, so here you have to use this. Okay, and if n is not a integer and if n is a fraction, then we need to use this. Okay, and one more term we have here is exponential term. Okay, so we know Laplace transform of e power at, okay, which is 1 over s minus a. Okay, but here we have a power t. We have a power t. Okay, and let us find Laplace transform of a power t. Okay, this is not generally given. We know this, and we have to make use of this to find this. Okay, how will we do that? A power t can be written as e power log natural a power t. Okay, so whatever the term here, we have to write it here. E power log, it can be written like this. It is same as a power t because these two are inverse of each other, inverse functions. Okay, so e power log or log e is 1. Okay, and and in the numerator and then in the power, log of a power t. So if you have something like log of a power b, you can write it as b log a. Okay, so I can write this as e power t log of a. Okay, and here log of a is a constant. So this a here is actually log of a in this case. Okay, e power some constant into t. E power some constant into t is 1 over s minus that constant, right? So e power, so this can be written as log of e power t log a, and this is basically 1 over s minus log a. So you can remember Laplace transform of a power t as 1 over s minus log of a, or you can do this every time and just remember log of exponential function e power at is 1 by s minus a. Okay, so you need to make use of these to solve this. Okay, so first let us expand the f of t. F of t given is a plus b whole cube. So what is a plus b whole cube? A plus b whole cube is a cube plus 3ab into a plus b plus b cube. This is very simple algebraic formula that you have learned long ago, and let me write this once again like this: 3a square b plus 3ab square plus b cube. I don't want bracket terms here. I want individual terms. That will be easy to take Laplace transform. So using this formula, f of t can be written as a cube, which is 3t whole cube, which is 27 t cube. 3 cube is 27, t cube is t cube, plus 3a square b. So a square is 3t square is 9t square. 3 times 9t square times 4 is another 27. 27 4 is 108. 108 t square. 3ab square. 3 into A is 3 into 3t is 90. B square is 4 square 16. 90 into 16 is 144 t. Okay. Plus 4 cube plus b cube plus 4 cube, which is 64, and plus 5 power t as it's. Don't forget to keep this. Okay. Now if you take Laplace transform of this, so Laplace transform f of t is f of s. Very simple from here. And this is equals to 27 Laplace transform of t cube plus 108 Laplace transform of t square plus 144 Laplace transform of t, or t to the power 1, plus Laplace transform of 64 plus Laplace transform of 5 power t. Okay. So this is f of s is now 27 as it is. T cube, t power n means n factorial by s, and 3 to all the powers here are integers, positive integers. So we will use this formula, n factorial by s of n, s power n plus 1. So n factorial means 3 factorial by s of n plus 1 means 3 plus 1 means 4. Okay. So plus 108 t square means 2 factorial by s power 3. Okay. Whatever n here, n factorial by n plus 1. Okay. Plus 144, 1 means t power 1 means 1 factorial by s square, plus 64. And Laplace transform of any number, Laplace transform of any number k is k over s. Again, this also comes from here only. K can be written as k into t power 0, right? Because t power 0 is 1 and k into 1 is k. So t power 0 means 0 factorial by s power 0 plus 1. So that will be 1 by s power 1. So that's what I written here, 1 by s. So 64 can be written as 64 over s plus Laplace transform of 5 power t is a power t is 1 by s minus log a. 1 by s minus log of 5. And ln is when you have e power. This is not natural log or base to the base e. Okay. And when you write log, it is to the base 10. Okay. So this is the Laplace transform of this function. You can simplify this further. 3 factorial is equal to 6, 2 factorial is equal to 2, 1 factorial is equal to 1, and multiply this and write. But that's how you should solve this question. Already known Laplace transforms. So the list of Laplace transform include Laplace transform of t power n, Laplace transform of e power at, using which I got Laplace transform of a power t, and simplifying this to individual terms, you can get the Laplace transform in these known terms, and then use the solution here. Okay. So let's see another question. So the simplest way to improve your CGPA is by studying the previous year question papers, and this works for all branches, any subjects. And for engineering math subjects, especially for M3, we have prepared an e-book, solutions to previous year question papers and model papers, that I think will help you enormously. Okay, I will leave the link to the e-book in the description. Please go check out our e-book. And if you are somebody who don't want to take any chances and prepare thoroughly for the examination, and if you are somebody who needs help understanding the solutions that are written in the book, you can check out our course, which is amazing and self-paced and very affordable. And I will leave the link to the course in the description. Please go check out our course.